Hello and welcome to my channel Learning with Sarita. In this session, we will discuss the topic electrostatic potential energy due to collection of point charges. First, we consider a source charge Q1. Now, I am going to bring a charge Q2 from infinity to this point. For bringing the charge Q2 from infinity, some work is done and it is placed at a distance r from the charge Q1. The potential at this point will be V is equal to K Q1 by R. To bring the charge Q2 from infinity, some work is done, isn't it? Here, for work done, we know the basic formula as the product of force and distance. Here I have a formula triangle for work done. You see, for work done, we use the formula product of force and distance. If this work is done in an electric field, our formula is work done is product of charge and potential. Here, the work is done in an electric field to carry an electric charge. So, work done in an electric field is work done is product of charge and potential. And to one more formula we have for work done is the product of power and time. Okay, now we are going to see how we got the formula work done is the product of Q and V. You see, W is equal to F into D. Now, the force in the electric field is QE. So, QE into D. The forces, Coulomb force and the external force are both opposite in directions. So, I introduce the negative sign. F is minus. So, minus QE into D. And we are bringing the charge from infinity. So, I introduce integration. Q minus integral infinity to point P E dot dr. For integration, we have to take infinitesimal distance dr. So, we know that minus integral infinity to P E dot dr is potential V. We get work done is the product of electric charge Q and the potential V. Here we are carrying the charge Q2. So, I write it as W is equal to Q2 V. This work done is nothing but the potential energy stored in the system. And so the work done W can be given as the potential energy U. W is equal to U and we know W is equal to Q2V and so U is also equal to Q2V and we get the expression U is equal to Q2 into 1 by 4 pi epsilon naught Q1 by V. That is the expression for potential V. And so we write electrostatic potential energy U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. Here you see, first I initially placed the charge Q1, then I brought Q2 from infinity and I got this expression. And even if I place the charge Q2 first and bring the charge Q1 from infinity, I will get the same expression. Okay, that is the potential energy does not depends on the order on which the charges are brought from infinity. It depends only on the position of the charges. That is depending on the distance between the 2 point charges. Here the concept hidden is the charges can be brought from infinity in any order. The electrostatic potential energy depends on the distance between the 2 point charges. So far we discussed the system with only 2 charges. Now we are going to see a system with 3 point charges. That is, we are going to find electrostatic potential energy for a collection of charges, collection of 3 point charges. Initially, all the charges are in infinity. Q1 charge is in infinity, Q2 is at infinity, Q3 is at infinity. First, I bring the charge Q1 from infinity to the point A. Okay, here when all the charges are in infinity, there will be no electric charge in this region. that is there will be no external opposing force. So easily this charge can be brought without any work done. That is, since F is equal to 0, work done is also 0. You see, for F is equal to 0, work done is 0. Therefore, no work is required to bring the charge Q1 from infinity. Once the charge Q1 is placed here, the Q1 charge will create its own electric field around it. Okay. Now, we are going to take the charge Q2 from infinity. So, on carrying the charge Q2 from infinity and placing it within the field created by the charge Q1, some work is to be done. So, what will be the work done to carry Q2 from infinity to this point? Work done is product of charge and potential. The charge here is Q2 charge and potential at this point is V1B. That is potential at the point B due to charge Q1. So, I write it as V1B. See here, work done in electric field on Q2 W is equal to Q2 V1B. So, this work done is nothing but the electrostatic potential energy stored. So, we can write W is equal to U1 is equal to Q2 V1B. So, for V1B, we substitute this expression and I get U1 to be 1 by 4 pi epsilon naught Q1 Q2 by R12. Now, I am going to bring the charge Q3. Here, since there are two charges here, Q1 and Q2, they both will be creating its own electric field around it, isn't it? Q1 has its own electric field and we placed Q2 within the electric field created by Q1, and this Q2 will also be creating an electric field. Now, when we bring Q3 from infinity, the Q3 charge is brought into the field created by both the charges Q1 and Q2. So, Q3 is entering into the field created by Q1 and Q2. Now, what will be the potential at the point C? Here the potential will be the potentials created by the charge Q1 and the potential created by the charge Q2. Work done in electric field on Q3 will be Q3 into sum of the potentials at C, that is potential at C due to Q1 plus potential at C due to Q2. We can write it as Q3 into V1C plus V2C. So, we give the expressions for V1C and V2C. We get work done W is equal to 1 by 4 pi epsilon naught Q1 Q3 by R13 plus 1 by 4 pi epsilon naught Q2 Q3 by R23. And so, the electrostatic potential energy U2 will be the work done, that is equal to 1 by 4 pi epsilon naught is taken as common into Q1 Q3 by R13 plus Q2 Q3 by R23. Okay, now we are going to find the total electrostatic potential energy of the system. Nothing but we are going to add the potential energies U1 and U2. So, on adding, I get the final expression U as 1 by 4 pi epsilon naught into Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. That is, the total electrostatic potential energy is the total work done to bring the charges from infinity to make a configuration, isn't it? Now, the Coulomb force existing there is a conservative force, and so the electrostatic potential energy is not depending on the order in which the charges are brought from infinity. It is depending on the position of the charges. Okay guys, I hope you all are clear in the concepts of this topic, and by the end of this session, we will take a quick review of all the concepts. The electrostatic potential energy U for collection of point charges. Initially, all the charges Q1, Q2, Q3 are all in infinity. First, we bring the charge Q1 from infinity and place it in the point A. Since initially there are no forces existing here, the work done is 0. Then we bring the charge Q2 from infinity into the electric field created by the charge Q1. And then we are going to bring the charge Q3 from infinity into the field created by both the charges Q1 and Q2. Total work done here is the total electrostatic potential energy. The total electrostatic potential energy of three charge system is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. Okay guys, I hope you all understood all the concepts of the topic electrostatic potential energy. After watching the video, smash the like button, share my video to your friends and well-wishers, and subscribe to my channel and travel with me to get full mark easily. Thank you.